So now let's look at some soil properties and what all they entail and how they help soils interact with plants to make them grow. So the three things we're going to look at this mini lecture is soil texture, aggregation and structure, and then soil chemistry. So soil texture is, in essence, what we describe as the fineness or the coarseness of a soil. So is it very clay? Is it sandy? Is it silty? Is it in between? What is it? And that's what we will then start to characterize what we're going to grow in that soil, what can and will grow in that soil, and then what will not grow in that soil due to the soil texture. So how we look at that are three main soil particles that we will go over this week, and that is sand, silt, and clay. And we'll go over their dimensions as well. And so sand and silt are the most inerrant silica, and they are very important because they're the ones that help mesh different soils to make cation exchange capacity present, make nitrogen present, and they kind of intermix with different particles to make sure that everything is working correctly. So with the most reactive particle, we have clay, and then that also then provides the most nutrients for plants. But like I'm sure many of you have played with clay or touched clay, you know that it's very hard, especially when it's dry. So there's got to be some other particles in there to help airflow, help water flow, and that's the kind of soil texture that we'll talk about this chapter or this mini lecture as well. So make sure you know this very well, because this is very important. So when people see sand, silt, and clay, they think of sand as being very small, because by the naked eye, when you see a sand particle, it's extremely small to you. But clay is actually the smallest, and it takes a microscope to actually see it. So clay, silt is the middle soil particle, and then we have sand, and you can have very fine sand that might take a microscope to look at, and then we have fine sand. So clay is the smallest, silt is the middle, and then sand is the biggest. This is a soil texture triangle, and this week I'm going to teach you in class how to read this. And so this is really important. So when you are, if you ever want to be a producer, even if you're just, you don't have to be farming or ranching, even if you just want to have a garden, it's really important to know what type of soil you're working with. And so I'm going to teach you how to do that, how to figure out what percentage of sand, silt, and clay are in your soil so that you can determine your soil texture. And this is a soil texture triangle that we use. It's very common. It's used worldwide, and we will look over that. So make sure you familiarize yourself with this soil texture triangle, because it'll be very vital to your points this week in class. So, soil structure. Why is it important? Soil structure is really important because that is how we figure out what we can produce in those ag soils. So we have different types of structure. We have anything from granular structure to platy structure, and figuring out how those soils will interact with plants is very important. So soil structure is just that clustering soil particles and how they are shaped. So now we're looking, we've looked at the texture. Now we're going to look at the shape of those soil clusters. And one very important term that we need to look at is tilth, and that is just the ease of tilling. How beneficial are these soils going to be in terms of ease of tilling, in terms of ease of working that ground for crop growth? So we've talked about texture, we've talked about soil structure. Now let's look at a little bit of soil chemistry. So cation exchange capacity, very important. That is just the amount of exchangeable cations that soil can sustain throughout the growing process. And so you can see that image there. You have some negatively charged particles and some positive charged particles. So the whole interaction between those particles, that cation exchange capacity, the higher we have that, the more fertile that soil is going to be. So the more organic matter we're going to have, the more productive plant we're going to have. So having those, so we see some potassium, we see calcium, having those interact with each other negatively and positively. And we learned a couple slides ago that clay has a negative charge, that clay particle has a negative charge. So having all of those positive charges like that potassium, calcium, hydrogen, those are very important to start to interact with that clay soil, so that all of those nutrients and minerals will start interacting and enhance that plant growth. So to look at cation exchange capacity, now let's look at the pH. So the pH just describes how concentrated those hydrogen ions are. So we looked at a couple of those ions. Now we're going to look at specifically the hydrogen ion. So I'm sure you've heard of what pH is and why it's important, but different field crops, different fruits and forage and vegetable crops need different types of pH ranges. So that will also influence how available those nutrients are within the soil. So again, that goes right back to soil texture and soil structure, because if we have different soil texture, if we have a clay texture, we're going to have a different pH, and that's where we're looking. So I want you to look at these field crops. Go down there on the top left part of this image, and you can see that a soybean there needs anywhere from 5.5 to 7 pH. All right, so now I want you to look, excuse me, now I want you to look at a black walnut tree. Okay, that needs anywhere from a 6 to an 8 pH range. So optimum pH range that we have for field crops is anywhere from a 5 to 7. So you can see on those field crops, it's anywhere from 5 to 7. Of course, oats and rye, they can actually go to a 7.5, as well as some corn, some wheat varieties, sorghum, and a little bit of barley. So optimum pH though is from 5 to 7. So salinity. Salinity is really important for crops. We're going to do a pretty fun lab this week with salinity and why it occurs. So that's just the accumulation of those soluble salts. So we know that soluble is when water interacts with it, it will dissolve. Okay, it's not going to just sit there. It will dissolve into that soil. So this is very common in dry regions. So we see a lot of salt in southern Oklahoma, Texas, those southern regions that are very, very dry. But the bad thing is, if you have a high concentration of salt, it can cause that breakdown of that soil structure. So if you have a granular structure, it's easy, has good tilth, so good ease of tillage, and then all of a sudden you get a lot of salt built up over a decade, it could really hurt that soil structure, which in turn would then hurt the soil structure, which would in turn then hurt the soil texture, and then the nutrients and availability of minerals as well. So why is it important to meet the needs of these plants by soil? Because, well, the whole point of it is to determine those nutritional needs for those different crop plants. So corn is going to need a different percentage of nitrogen than soybeans. So we need to figure out how we're going to emphasize and put that nitrogen down, and soil has a lot to do with that. Fertilizers, are we gonna be organic or inorganic fertilizers? Are we gonna have are we going to be an organic or inorganic grower? And then the best nutrient management practice for that ground, to be a stewardship of that ground, is very, very important. So this is a soil nutrient test level. So we're just looking at the relationship between the soil nutrient levels and the yield. So you can see the yield there on the left-hand side, and the soil nutrient, the soil test nutrient level. So when we get to about level 3, that's going to be where that peak of yield would be. So it's really important to know what nutrients and minerals are present in your soil, maybe what deficiencies you have, and how important that is to make sure that you're growing those crops efficiently as possible.